In this video, we are going to be verifying trigonometric identities. Let's start by looking at this word verify. To verify something means to prove or demonstrate that something is true. For our trig identities, we're going to be using our little arsenal of tools. So far we have the Pythagorean, the quotient, and the reciprocal identities. Now, here are some methods that you can use to kind of give you some guidelines in verifying what you want to verify. And they're really the same things that we've done in simplifying. So you can apply your known identities, however these apply up here. You can factor, you can combine fractions, you can multiply by the conjugate, and much more. This is a lot like last lesson, except you have kind of an end direction. Let's get into some examples, and hopefully you'll get the hang of it. Let's see if we can verify the following identity. Here we want to prove that cosecant squared x minus 1 all over cosecant squared x equals cosine squared x. So first, let's start with this left side. Looking on top, I see that I have cosecant squared x minus 1. This should make me think of my Pythagorean identities. And actually, I can replace this cosecant squared x minus 1 with a cotangent squared x. Alright, going on from here, I have cotangent squared x over cosecant squared x. Let's see, I don't have any Pythagorean identities, I can't combine any fractions, so why not write this in terms of sine and cosine? Starting with cotangent squared x, using my quotient identity, I know this is equal to cosine squared x over sine x. So I just replace cotangent squared x with cosine squared x over sine squared x. Now I have this cosecant squared x. I know cosecant squared x has a reciprocal of 1 over sine x, but this is in the denominator of the fraction, so this is kind of like I already have 1 over cosecant squared x, which I know is equal to sine x. So I can replace 1 over cosecant squared x with sine squared x. From this point, I see that I have a sine squared x on the bottom and a sine squared x on top. Those are going to cancel each other out, leaving me with just cosine squared x, which, if I look at what I wanted to verify, is exactly what I wanted to prove, and we did just that. So check, we verified this identity. Here we want to verify 1 over cosecant x plus cotangent x plus 1 over cosecant x minus cotangent x equals 2 cosecant x. Alright, usually when you have a big mess like this, that's a clue you want to combine your fractions. So let's get a common denominator. My common denominator is going to be cosecant x plus cotangent x and cosecant x minus cotangent x. So since the left side here is missing the cosecant x minus cotangent x, I'll times that top and bottom. The right side was missing the plus, so I times that top and bottom. After I simplify all that by multiplying and then smashing it all together, I'm going to get cosecant x minus cotangent x plus cosecant x plus cotangent x all over the common denominator. So looking at our numerator, let's combine our like terms. I see cosecant x plus cosecant x. That's going to give me 2 cosecant x in the numerator. Then I have negative cotangent x plus cotangent x. Those will cancel out. So that's the only thing I have in my numerator. Looking in the denominator here, I'm going to have to distribute all of this out. And as a side note, these look like conjugates, so I know some things are going to cancel out. Distributing this whole denominator out, we're going to get cosecant squared x minus cotangent x. Alright, what can we do? What can we do from here? Looking at let's go back to what we want to prove. We want to prove that this was all equal to 2 cosecant x. Looking at where I'm at, I have a 2 cosecant x in the numerator, so that might be a clue to me that this denominator should cancel itself out somehow. Well, if I manipulate one of my Pythagorean identities, I get cosine squared x minus cotangent squared x equals 1. Since my denominator is 1, that's just going to leave me with 2 cosecant x, which again is exactly what we wanted to verify in the first place. So I'm going to put my little check mark and say done, verified. Let's try this one. Sine alpha over 1 minus cosine alpha equals cosecant alpha plus cotangent alpha. Alright, looking at my starting point here, I see that I already have only one term, so I can't combine fractions. There's nothing no square terms, so no Pythagorean. I already have sine and cosine, so my best bet is probably going to be to multiply by the conjugate of the denominator. That's going to be 1 plus cosine alpha multiplied to the numerator and the denominator. If I distribute all of those out, I'm going to get sine alpha plus sine alpha cosine alpha over 1 minus cosine squared alpha. Going from here, let's see if we could recognize what to do next. Well, in the denominator, I see 1 minus cosine squared alpha. I should be thinking Pythagorean, and this 1 minus cosine squared alpha can be replaced with sine squared alpha. That's going to leave me with this guy down here. All right, looking at this now, I'm looking at my numerator. I see a sine alpha here and a sine alpha here. Those are both in common, so I probably can try factoring those out, especially since I see a sign on the bottom. I know something's going to be able to cancel. So let's take the numerator and factor out a sine. That's going to leave us with sine alpha times 1 plus cosine alpha all over sine squared alpha. Now, kind of funny here, I just went full circle back to here. Sine alpha 1 plus cosine alpha. Sine alpha 1 plus cosine alpha. So sometimes when you distribute, you might end up going back in the reverse direction depending on where you end up. You can always try to distribute first and go back, or you don't have to distribute and wait till later to see how it works out. Anyway, this is what we're left with. Now we have a sine alpha, a sine squared alpha here. We're going to be able to cancel out this, and we'll be able to cancel one of our squared on the bottom, leaving with just sine alpha in the denominator. Going forward, I have 1 plus cosine alpha all over sine alpha. Okay, here I don't have a conjugate. I already have sine and cosine. What can I do from here? Now this is a trick that you might want to pay close attention to. Looking back at what I want to prove, I see I want to prove cosecant x cosecant alpha plus cotangent alpha. Going down here, I don't have anything of the sort. So what you can do sometimes here is you can separate fractions. In fact, why don't you add that to your list? I left it out in the beginning. There we go, separate fractions. Sometimes it's going to be necessary to do that. So we're going to reverse combining our fractions now. Check this out. That's going to leave us with 1 over sine alpha plus cosine alpha over sine alpha, right? If we combine these, they have common denominators. That would be 1 plus cosine alpha over sine alpha. We went backwards, splitting this fraction up. Now that we have 1 over sine alpha, what's that equal to? Well, 1 over sine alpha, if I use my reciprocals, that will give me cosecant alpha. Then I have cosine alpha over sine alpha. If I use my quotient identities, that'll give me cotangent alpha. And whoop! That's exactly what I wanted to get to. Cosecant alpha plus cotangent alpha. Whoop. Cosecant alpha plus cotangent alpha. Check. Hang in there for just one more and I'll send you off to try them on your own. Here we have cotangent theta, secant theta, cosecant squared theta minus cotangent cubed theta, secant theta. And we want to verify that it equals cosecant theta. Whoa, what a change from all this only down to cosecant theta. All right, looking at this here, since I have two big terms here, my guess is we're going to be able to factor. Let's see if we have anything in common. I have cotangent and secant, cosecant. Here I have cotangent and secant. Well, I have a cotangent theta in both, and I have a secant theta in both. So let's factor that out. That'll leave me with cotangent theta, secant theta, cosecant squared minus cotangent squared. All right, from here, looks like I'm getting somewhere. This cosecant squared theta minus cotangent squared theta is actually one of the Pythagoreans, and this is going to all simplify to 1, leaving me with just cotangent theta, secant theta, right? Because this is all 1, so times 1 would just be this. Now that I have cotangent theta and secant theta, all right, somehow that needs to get to cosecant theta, so what's often best in these scenarios is change everything to sine and cosine and see what we're left with. That's going to give us cotangent theta changed to cosine over sine using our quotient, and secant changes to 1 over cosine using our reciprocal. And check this out. Boom, boom, our cosines are going to cancel, leaving us with just 1 over sine, but we know that 1 over sine using our reciprocals is cosecant theta, and that's exactly where we wanted to end up. So all of that changes to cosecant theta. Check. Again, just like I've been saying this whole unit, the more you practice these, the more you get the hang of manipulating them, and it gets easier and easier. Have some fun. You'll know your answers right once you get to it. Just make sure you stay consistent with all your rules.